Welcome to this comprehensive tutorial on Python variables and data types. We'll explore these fundamental concepts in depth with clear explanations and plenty of visual examples to help you grasp these essential programming building blocks. In programming, a variable is a fundamental concept that acts like a named container or storage location in your computer's memory. Think of it like a labeled box where you can store different types of information. Each variable has a unique name, called an identifier, which you use to access its stored value. When you create a variable, Python allocates space in memory to hold its value. Let me show you a concrete example. Here we have a variable named my_var that's storing the number 42. The variable name, my_var, acts like a label on our memory box, while 42 is the actual value stored inside. In Python, we would create this with the simple statement, my_var equals 42. The equals sign here is called the assignment operator, which assigns the value on its right to the variable name on its left. Here's how this variable creation looks in actual Python code. The line, my_var equals 42 feet creates our variable and assigns it the integer value. Notice that in Python, we don't need to declare the variable type beforehand. Python automatically determines the type based on the value we assign. It's important to follow certain rules when naming your variables in Python. A variable name must start with either a letter or an underscore. The rest of the name can include letters, numbers, and underscores. Remember that Python is case sensitive. So, my_var and my_var are treated as different variables. Also, you cannot use Python keywords, which are reserved words with special meanings in the language, as variable names. Now let's explore the different types of data that Python can work with. These data types are the fundamental building blocks of all Python programs. Each type serves a specific purpose and has different characteristics. Understanding these types is crucial because they determine what operations you can perform on your data and how Python stores it in memory. Let's examine Python's main data types in detail. Integers represent whole numbers like 42, with no decimal points. Floating point numbers or floats represent real numbers with decimal points like 3.14159. Strings represent text and are enclosed in quotes. You can use single or double quotes. Booleans represent truth values, either true or false, which are used for logical operations. Lists are ordered collections of items, shown here with square brackets. Dictionaries store key-value pairs, enclosed in curly braces, like this example storing a name. Let's focus first on numeric types. Integers are used for counting and discrete values, while floats are used for measurements and continuous values. An important difference is that integers are exact, while floats have limited precision due to how computers store decimal numbers. Both integers and floats support arithmetic operations. Here we see examples of addition, subtraction, multiplication and division. Notice that operations between integers produce integers, except for division, which always produces a float. When you mix integers and floats in an operation, Python automatically converts the result to float. Now let's examine strings more closely. Strings represent textual data and are immutable, meaning once created they cannot be changed. Python provides many operations for working with strings. Strings can be concatenated with the plus operator. You can access individual characters using indexing. The len function gives you the string length. There are also many useful methods like lower to convert to lowercase. Now let's look at two very important collection types. Lists and dictionaries. Lists are ordered, mutable sequences that can hold items of different types. Dictionaries store key-value pairs for fast lookups. Lists support operations like concatenation with plus. Dictionaries let you store values accessible by keys, like looking up Alice's age in this example. These collection types are incredibly versatile and used constantly in Python programs. To truly understand variables, we need to see how Python stores them in memory. Each variable is a reference to an object in memory. And Python's dynamic typing means a variable can reference different types of objects at different times. Here's a detailed view of how variables live in memory. Each variable has its own space storing both the value and its type. The age variable stores an integer. Price stores a float. Name holds a string. And is_student contains a boolean. Python keeps track of each variable's type automatically, which is why we call it dynamically typed. The memory addresses shown here are simplified. In reality, they would be hexadecimal numbers, representing actual memory locations. An important concept is that variables in Python are actually references to objects in memory. Multiple variables can reference the same object, which affects how changes propagate. Here we have two variables, x and y, both referencing the same list object in memory. When we modify the list through either variable, the change will be visible through both references. This is different from some languages where variables contain the actual values rather than references. Often we need to convert between different data types. Python provides built-in functions for these conversions. But we must be careful about potential data loss or errors during conversion. Let's convert the integer 10 to other types. Using float gives us 10.0. The str function converts it to the string 10. Using bool gives true, since any non-zero number is considered true in Python. These conversions are explicit. We're telling Python exactly what we want. Not all conversions work. Trying to convert the string hello to an integer raises a value error, since there's no sensible way to perform this conversion. This is why we need to handle such cases carefully in our programs. Let's put everything together with a practical example. Converting temperatures between Celsius and Fahrenheit. This will show how variables and data types work in a real programming scenario. We start with the temperature in Celsius stored in a float variable. The conversion formula takes this value and calculates the Fahrenheit equivalent. Both values are floats since temperature measurements often need decimal precision. Here's the actual Python code that would perform this calculation. Notice how we use descriptive variable names to make the code more readable. In a real program, we might get the Celsius value from user input, which would come as a string that we'd need to convert to float before doing the calculation. This demonstrates how type conversion happens naturally during program execution. Let's summarize what we've learned. Variables are named references to data in memory. Python provides several fundamental data types for different purposes. We sometimes need to convert between types. It's important to choose appropriate types for your data and understand how variables reference objects in Python's memory model. These concepts form the foundation for all Python programming you'll do. You now have a solid understanding of Python variables and data types. With this foundation, you're ready to explore more advanced Python concepts. Happy programming!